Hey, ladies and gentlemen, sorry I couldn't be here today, but I still really hope that you're just as respectful for the sub as you would be for me. Okay, we'll be going over some of your questions tomorrow, so don't worry about that. But please work really hard for the sub today, and I really would appreciate that. So let's take a look at number 1. So this is the same thing we did yesterday, but today what we're going to do instead is we're going to do a little extra step, and we're going to factor things before we start multiplying. So when I take a look at x squared minus 2x minus 15, I'm going to go ahead and factor that. Now, here's a little trick that I'm going to show you that I haven't showed you before. If that's equal to 1 right there, you can immediately put that into factored form. Since we're mostly going to be doing when things are equal to 1, we can put that into factored form. So factoring that bottom, we get x minus 4, x plus 3. If that doesn't make sense to you, you can still go back and do it this way. Okay, this way always, always, always works. So if this way is just as fast for you, feel free to do that as well. Either way, I just want to maybe save you guys some time if need be. Okay, so there's your factored form. So what I'm going to do is I'm going to rewrite out number 1, and I'm going to write them as multiplying as I do so. So on the top, I have x minus 5 times x, and on the bottom, x squared. On the bottom, x. Now, instead of writing x squared minus 2x minus 15, I'm going to write it as a bunch of factors being multiplied. Okay, so first thing we want to do is simplify x squared over x. So when I simplify that out, I'm just left with that x on top. Now I notice I can cancel out x minus 5 and x minus 5. And then left on the bottom is x plus 3. Now the one thing I did forget was to take the excluded value from the beginning. So I need to take all 3 of these and set them equal to 0. So x is equal to 0, x minus 5 is equal to 0, and x plus 3 is equal to 0. So solve each of those for x, and you end up that x cannot be 0, 5, or negative 3 for that excluded value. Okay? Next, let's take a look at number 2. So again, before I go ahead and I do that, I'm going to factor that out. So 3 and 4. So what I want you to do right now is pause the video and get that all factored. Okay, so once you've done that, you're left with 5 times x plus 3 over x times x plus 3, x plus 4. Now, before I get too excited, I'm going to go ahead and quickly calculate out my excluded values. So I'm going to take my denominator right now. I'm taking the denominator right after I multiply it, and I'm setting that equal to 0. So I'm taking each of these factors and setting them equal to 0. So then my excluded value is that x cannot be 0, negative 3, or negative 4. Okay, now I want to cancel some things out, okay? I can't cancel that x out with anything because there's no thing that's just an x on top. Everything is included in a factor. In fact, what I see overlapping is this x plus 3 and this x plus 3. So I'm going to cancel those out. So everything has to be multiplied for it to get canceled out. So then on the top, I have 5, and on the bottom, I have x times x plus 4. And that's my final answer for that one. Okay, let's take a look at number 3. So again, first thing I want to do is factor. So I'm going to set up my x, multiplying to negative 4, adding to negative 3 is negative 4, positive 1. So once I factor that, if you go through, you can do the work on your paper if you want, y minus 4, y plus 1. But I'm going to save the time on the video talking about factoring. So let's start rewriting this out in factored form. So on top, we have y minus 4, y plus 1. On the bottom, y plus 5. And then here on the top again, because we're multiplying, this is also going to go on the top. I have y plus 5. Okay, so on the bottom here, I have y plus 5, but I also have to account for this guy right here. So I have y squared minus 4y. So I can't necessarily factor that using the x, but what I do notice is that each term has a y. So I can factor out a y, and then I'm left with y minus 4. So again, before we get too far, I'm going to look for my excluded values. So I'm going to do y plus 5 times y minus 4 and set that equal to 0. So I'm going to set each of those parts equal to 0 and then solve for y. Okay, so when I do that for my excluded values, I get that y cannot be -5, 0, and 4 for my excluded values. Now let's go back and find our simplified version. So I'm going to cancel out y minus 4, and then I can cancel out y plus 5 because everything's being multiplied. So I still have a y here left over, and I still have a y plus 1 left over on top. So that is my simplified version right there. Okay, I want you guys to go ahead and let's set up number 4, and then I'm going to have you guys try it on your own. So let's get it all factored out for you. So we have b plus 3. Factoring this guy right here, you're going to get b minus 1, b minus 4, or minus 3, sorry. And then here, we're going to take out a greatest common factor of 4. That's leaving us with b minus 3. Factoring that guy down, you're going to end up with b minus 10 and b plus 3. So I want you guys to find the excluded values, and then I also want you to go ahead and simplify that down for me. Let's take a look at number 5. So for number 5, we're going to, again, multiply some of this out. So before I do that, I want to factor. So for 12, I'm multiplying to 12, adding to 7, which is 3 and 4. So again, I'm not going to take the time to go over the factoring on the video. If you're still struggling with factoring, please let me know. So on the top, you're going to have this x squared times x minus 5. On the bottom, x. Now I'm going to write this out in factored form. So instead of writing x squared plus 7x plus 12, I'm going to write that in factored form. Now we need to go through and calculate our excluded values before we do any simplifying. Okay, so let's start with that. So I'm going to take x times x plus 3 times x plus 4 and set that equal to 0. Now that means I need to take each of these factors and set them equal to 0. So go through and solve each of those for x, and you get for your excluded value that x cannot be 0, -3, or -4. So that's one of my two answers. Now I want to go through on this next one and cancel out what I can. Well, here I have x squared over x to the first. So when I cancel that out, that's going to cancel out to x. And then on top, I'm left with x minus 5. On the bottom, x plus 3, x plus 4. So if you notice, none of our factors canceled out there. Some of our x's did, but none of our factors did. That extra x that's on the outside can't be canceled out with anything outside of the x's right here, because they're not being multiplied because of these addition signs right here. So we'd only have to do factors. Now, taking a look at number 6, let's get this set up. Okay, then I want you to cancel it out. So x minus 3 is going to stay the same. Now, factoring this guy right here, multiplying to a positive 6, adding to a -5, -3 and -2. So I'm going to write that out, x minus 3, x minus 2. Now, I don't want to leave this as 2x minus 4. Here's what I tell students. When you're doing this, when in doubt, just factor everything. Okay, if you don't know what else to do, just start factoring. So we can take a 2, and we're left with x minus 2. And then if you're going to factor that guy right there, multiplying to -6. So then you're going to have x minus 3, x plus 2. So I want you to go through, find the excluded values, as well as simplify that down for me. Let's take a look at number 7. Okay, so this one is going to use differences of squares. So that's the one where we set up the x. We want to multiply to -1 and add to 0. So to do that, we're actually going to have x plus 1 and -1. Okay, if we were to go through and factor that top part. Same thing here. This is the same as multiplying to -25 and adding to 0. So we're going to use 5 and -5. Again, if you need to take the extra time to go through and factor that yourself, that's fine. Okay, so that's x plus 5 x minus 5. So all I'm doing as I'm factoring is I'm writing all of the factors on the same line. Now, factoring this one, multiplying to 10, adding to negative 7, negative 5, and negative 2. If you need to take the time to factor that out, that's fine. I'm going to do it in my head. Here, for this one, multiplying to 5, adding to 6, that's 5 and 1. So we have x plus 5, x plus 1. So now we're going to take each of those factors on the bottom and set them equal to 0 to get our excluded values. So this one's going to have a lot of excluded values. So when you solve each of those for x, you get that x cannot be 5, 2, negative 5, or negative 1. Okay, so that's your excluded values. Let's write this out in simplified form. Well, here I have an x plus 1 that can cancel out with an x plus 1, x plus 5, x plus 5, x minus 5, x minus 5. So in this one, all I'm left with is x minus 1 over x minus 2, and that is your simplified version. Okay, let's take a look at number 8. There are 25 lights around a patio. If each light is 40 watts, the cost of electricity is 15 cents per kilowatt per hour. Write an expression to calculate the cost of using the light for 3 hours. So what we're trying to do here is do some elimination. So we want to kind of get rid of labels to get to the final answer that we want. Okay, so we're going to start with the fact that we have 25 lights. Now look at per as being dividing. So we have 25 lights. It says each light is 40 watts. So there's 40 watts for every one light bulb. Okay, so that's going to cancel out that light label. So now I have things in watts. Okay, then we want to talk about kilowatts. Okay, so kilowatts means 1,000 watts. Kilo means 1,000. So I want to cancel out watts and get kilowatts. So since kilo means 1,000, for every 1 kilowatt, which I'm going to label kW, it's 1,000 watts. Okay, then it says it costs 15 cents per kilowatt. So there's 15 cents for 1 kilowatt. So here I've canceled out watts. Now I've canceled out kilowatts. And I want to calculate the cost of using the electricity for 3 hours. So right now I have it to cents. So I want to multiply that amount of cents by 3 hours. So now all we're going to do is multiply and divide straight across. So I'm going to take 25 times 40 divided by 1,000 times 15 times 3. And when you multiply all of that together, you end up with 45 cents. So it costs 45 cents to run those lights for 3 hours. Let's take a look at number 10. In the 2004 Summer Olympics in Athens, Greece, Justin Gatlin of the United States won the gold medal for the 100-meter sprint. So he did 100 meters in 9.85 seconds. So he did 100 meters in 9.85 seconds. What was his speed in kilometers per hour? So kilometer, again, means kilo. So there's, for every 1 kilometer, there's 1,000 meters. So now I've canceled out that meter label, which is good. But now I have to get my hour label. So I need to figure out how many seconds are in an hour. Think about it this way. 60 seconds in a minute, and then there's 60 minutes in an hour. So that's 3,600 seconds per hour. So again, you're just going to multiply and divide all of that. And then you're going to end up with 36.55 kilometers per hour. I'm going to go ahead and get number 11 set up for you. So why don't you go ahead and pause the video and just read through that question. Okay, so here's the setup for number 11. So we're going 40,320 kilometers in 1 hour. They ask us what is the meters per second. First of all, we know there's 1,000 meters per kilometer. So now we've canceled out those kilometer labels. Now we need to cancel out the hour with seconds. Well, we just talked about how there's 3,600 seconds in 1 hour. So I want you to multiply out and then divide those and write what you get. Last but not least, I want you to try number 12 on your own. We'll talk about it more tomorrow. I think you can do it, or at least get something written down that you've tried on. Go ahead and show the substitute your note sheet and ask politely for a homework, and I will see you tomorrow. Have a great night.